So that's what happens. The picture of it is like this in the book. There's like two sources of awareness. The person is aware the stimulus is out there. This, of course, is relevant to the consciousness discussions. The person has no conscious feeling states from one of them, and therefore it really is kind of robotic zombie-like when drawing the saw. Well, this also works this way. If there's a screen there are many studies like this. If there's a screen, so the person can't see past the screen, and you flash this up, the person will say ring, and then will reach around with his or her left hand, can, of course, recognize objects by feel, and will pick up the key. And then you'll ask them why, and then they'll say, oh, well, I need an extra key for my house. By the way, we won't stop and show the person. It turns out if if it's like too heavy and you really don't, apparently you can get by without the entire brain. Here's the girl with half a brain to fight seizures. That seems fine. Cameron Mott stunned doctors with her miraculous recovery. Children adjust to this, get rid of half of it, pretty well. Can run, walk with a bit of a limp. Hand functions on the side opposite to the surgery is impaired, but even when the language hemisphere is removed, children typically regain a considerable amount of language skills. So there's this stuff at the beginning of the chapter, in the beginning of our discussion, brain plasticity, it's really an enormous effect, so enormous that if you lose the language side very early in life, you'll still have language. I mean, this is kind of mysterious how this works, because there are so few cases. But you will regain some language use way before your time. Somebody, as you learned in some history class, tried to assassinate Ronald Reagan. There was more of an injury to Ronald Reagan's press secretary, who was totally non-linguistic after the accident, but was fairly linguistic like 4 or 5 years after the accident. Even in adulthood, recovered some of these language functions after losing some of the left hemispheric stuff for language. Then there's more brain in the back. Oh, why did I take off the pictures? In the back, there's another, like, in a sense, little thing that's like a little miniature brain, which is called the cerebellum, which translates into something like little miniature brain. This for a psychology class is less utterly critical than some of the other things, but you can see what the cerebellum does. So if you tell the evolutionary story, which is obviously not hard to tell and it's got to be correct here, in addition to a motor cortex, it was so important to have smooth movement to be able to escape from predators a little more smoothly than that poor unfortunate person could, to be able to throw something with accuracy that hits something. Another one of those things humans do that is kind of surprising that you can do it so well. I mean, there's a few of these where, like vision of faces, you remember the person. It's kind of amazing that you can, we just take it for granted because we're humans, all of us here. If you watch a sporting event, it is kind of amazing that the person can throw the football and it lands in the other person's hand, and the other person is running like 21.5 miles an hour, and it's 200 feet away. There's a level of motor coordination that we see in a whole range, the same thing with gymnastics. How the heck does the person jump up in the air, flip upside down, and land on the beam? It's crazy. It would be perfectly imaginable that humans couldn't do that at all any more than they could fly. But what happens is you want your cerebellum for that. Over the course of evolution, fine motor control was so important that there's a huge subunit of brain devoted specifically to fine motor coordination, the cerebellum. Without it, you've got really bad motor coordination. Here's my strategy for this class. I'm heavily emphasizing the top and not the bottom. As one moves down in the brain, one reaches other systems that will show up here in the last 14 minutes of class. As you go further down, sooner or later it starts to look like your human anatomy class or some biology class you took in high school. The functions that are the biological tools needed for all the psychology we had in the first 13 weeks of the class, are clearly up top. Without all the up top cortex stuff, you're not going to have social attitudes or a personality or these forms of memory, et cetera, et cetera. You'll still have other stuff, but you won't have the interesting psychology. You do need the limbic system for a whole host of bodily maintenance functions and emotions. So again, when we did the consciousness chapter, animals looked like they were really mad at the predator or something, or running or afraid of it. And frogs didn't, and they were just sitting there. I'm a frog. Because the mammals had a limbic system. So the limbic system is a slightly arbitrary name, or is a name for a slightly arbitrary collection of interconnected but anatomically independent brain systems that sits below the cortex, but of course are highly connected to the cortex. I'll just point to a couple of them. So the hypothalamus we had some discussion of already in the motivation chapter. It's important for body maintenance, maintenance of hunger, thirst. There's a whole bunch of other things like body clock regulation that the hypothalamus does. There's something called the cingulate gyrus, this kind of aqua-greenish structure, only in this picture. I learned in class it's green. That's important, has a very distinctive function that once you think about it, you realize is a distinctive function and is very important. You're reaching for something, oh, it's hot, I shouldn't do that. You're walking in this direction, oh, there's a car coming. Or on the Stroop task that we had way back when the course started, the letters go up and you're supposed to say red, but they say green. It's a trick. It is the case that reading is so automatic that you first say green, but if you're doing the task correctly, you stop yourself, and you stop yourself because the cingulate gyrus is there. If you damage the cingulate gyrus, the person's really bad at the Stroop task, is the idea. Switching tasks from reading the letters to reporting the color of the font, that's what they mean by switching tasks, in a very short amount of time, recruits, for whatever reason, I don't know at the level of detail of the plumbing of the anatomy, but recruits the cingulate gyrus, which you need for task switching.